Welcome to our VisKo demonstration, in which we use our visualization query language to render a seismic velocity model. I'm Nicholas Del Rio of the CyberShare Center here at the University of Texas at El Paso. I will begin by defining a velocity model and presenting some motivation for why these models need to be visualized. I will then move on to presenting two fundamental rendering techniques, isosurfaces and volume rendering, and proceed to demo how we can use VisKo to generate these renderings using our velocity model data. Seismic velocity models represent 3D regions below the Earth's surface and depict the speed at which sound propagates through subterranean material. From the speed, the density and type of material can usually be inferred. From the type of material, we can infer structures that exist within the region, such as water tables and oil deposits. Like most data nowadays, the models are large and not easily tractable. Therefore, visualization is one technique for supporting the analysis of these large models and may provide scientists with an overall understanding of the data and thus the Earth's crustal structure. Velocity models are generated by tomographic algorithms that require many lengthy iterations. It is thus desirable to inspect these models intermittently to verify if they are converging before waiting until the entire process has completed. Convergence can usually be verified quickly through visual inspection. Suppose we want to render a velocity model as a set of isosurfaces, which are the three-dimensional analog of isolines or contour lines as they are commonly referred to. An isosurface represents points of a constant value within the volume of space. Consider the presented image of a molecule with an isosurface enveloping half of the structure. Every point along the blue surface has the same value. We will now demo how to use VisKo to visualize a velocity model as a set of isosurfaces. From our VisKo homepage, we navigate to the query language page by way of the link in the navigation bar. We then navigate to the query submission box. Once there, we can enter a query. For this example, I am pasting a set of prefixes that will make the query more readable. I can then specify what view I want VisKo to generate by way of the select keyword, followed by the URI of the view, which in this case is iso-surfaces1. We then need to specify what viewer will be presenting the generated isosurfaces images, in this case Mozilla Firefox, which has the URI of Mozilla-Firefox1. Once we have specified both the view and viewer, we need to specify what data will be visualized using the from keyword, followed by the URL of the dataset published on the web. Finally, we need to specify both the format and type of the dataset. In this case, binary float array with the semantic type of velocity data encoded as D2, a data type whose description can be found in an RDF document published on the web. We can then submit the query, and we will be presented with the query result page, which shows the query that was entered, as well as any results returned. In this case, we have one result, which if we click on will provide us with the visualization that we are requesting. Here we see the isosurfaces images, If we navigate back to the query result page, we can also look at the pipeline that derived that result. Here we see a list of operators. Each operator is responsible for transforming the dataset into its visual form. We see that each operator is associated with a set of parameters, and a value bound to that parameter. Upon clicking on any of these operators, we are provided with the RDF document describing the capabilities of that specific operator. This is what is known as visualization knowledge, and it is this knowledge that VisKo uses to reason to automatically build these pipelines. Here you can also take a look at the description of the viewer that we specified, Mozilla Firefox. Once again, another RDF document. Can we specify a different view using the query? Suppose we want to render the velocity model as a three-dimensional volume rather than a set of isosurfaces. Volume rendering is a technique for visualizing sampled functions of three-dimensional data. The technique computes 2D projections of a colored semi-transparent volume. Consider the volume image generated from a set of CT scans of a forearm, with different color schemes for muscle, fat, bone, and blood. Notice how you can see the bone structure through the semi-transparent muscles. Let's see how we can change our existing query to specify volume rendering. We can navigate back to our query submission box and reuse part of our isosurfaces query for the new query that will generate the volume. We simply need to change the text iso-surfaces1 to volume1 to indicate that we want a volume rendering of the velocity model. Notice that the other properties of the data specified in the query remain the same. We can then submit our query and we are presented with the result page, once again with a single result. If we inspect the pipeline for the visualization returned by this result, we'll notice a different set of operators composing the pipeline. We can navigate back to the result page and click on the visualization. Here the system generated our volume rendering. As you can see that part of the features of the data are evident through the semi-transparent surface. To execute more VisKo queries related to the velocity model or other data such as gravity and aerosol time series data, please navigate to trust.utep.edu/visco/ql. The page includes the VisKo query grammar, the query submission box where you can enter your own queries, and a plethora of prefabricated queries that you can execute by simply cutting and pasting into the query submission box.